Hi folks, welcome to day 16. Today we're going to be learning how to transform radical graphs. So last week we learned all about rational exponents and radical functions and how we could go between the two. And today we're going to be learning about how to transform radical graphs. So a radical graph is something like we had something like -2 times the square root of x minus 5 plus 4, right? Something like that is what we would call a radical equation because it has a radical in it, right? We learned that last week. But there's an easier way of graphing this other than just making a t-chart, which you can always do, but it's actually easier if you treat this radical as instead of like a giant function, if we break it down, we can actually split it into its parent function and then transform that. All right, so this is actually a throwback to trimester A, regardless of whether you took that in first or second trimester. You covered transforming parent functions, and we transformed the parent functions, the absolute value of x, which looks like that, and the quadratic function, which looks like that. Right? So we're going to do the exact same thing with our radical function, and our radical function looks like that. All right? Now I do go through in the paper notes, I do go through how to technically graph it in terms of making a t-chart, but given the fact that we are in the middle of a pandemic, I want you to know the concept of how to do this rather than nitpicking on the specific points. Because I think that the concept is a lot more important. So this is gonna be our key piece of notes for today, is like the fact that this parent function can be transformed. All right, so there are 4 types of transformations. All right, so we have translations. And remember, what's important with translation is this middle part here, this SL, that tells us that we need to slide the graph. That's what a translation does. And I'll let you know when it comes to what this actually looks like in an equation. That looks like x minus h plus k. All right, this should sound familiar. Now with this, we have this x minus h part. So x minus h means that we're going to be moving to the right. So if we have x minus a number, then we're moving to the right. If we have x plus h, x plus a number, we're moving to the left. So for example, if we had the square root of x minus 3, what we're going to do is we're going to take our square root of x and move it 3 to the right. All right, so we're moving it over 1, 2, 3, take our starting point, take it from the center, move it to the right, everything else about the graph stays the same. Same exact concept if we had like the square root of x plus 2. All right, so normally we have our square root of x plus 2 tells us that we need to move it to the left, 1, 2, moving it to the left 2, everything else stays the same, so then we have the square root of x plus 2. All right, then we get to this k piece. All right, now this k piece tells us, all right, if there's a positive number, you're going to move up. And if it's a negative number, you're going to move down. So, for example, maybe I want to move up, so I have the square root of x plus 2. Well, let's go ahead and erase some things over here. So we have the square root of x plus 2 means that I'm going to move my graph up 2. There we go. Now we have a clear playing field. All right, so we're going to take our square root of x, but we're going to move it up 2. So everything else about it stays the same. All right, and that's the hard part when I'm drawing without any like grid lines. It's hard to keep it exactly the same, but that's okay. So that's how I get the square root of x plus 2. Or if we had something like the square root of x minus 3, that means we're going to go down 1, 2, 3. All right, again, everything else stays exactly the same. All right, so that's translation. Translation's all about sliding your graph up, down, or left and right. Remember, up and down is with this plus k piece. Left and right has to deal with this x minus h piece. All right? After translation, we have reflection. What's important about reflection is that it lets you flip the graph, all right? So this FL reminds me that, okay, I'm going to flip a graph, and I'm going to flip over the x-axis. All right, and what that looks like is that looks like at y equals negative the square root of x. All right, so if we had our square root function, y equals the square root of x, reflecting over the x-axis means I'm mirroring over the x-axis. All right, and that's how we get y equals negative the square root of x. All right, so it's just a perfect flip over, a mirror over the x-axis. That's all a reflection is, and that's denoted by that negative sign. So there's 2 more that we're going to go over. All right, number 3 is a stretch, and number 4 is a shrink, but they are the same equation. So we have y equals a times the square root of x. If a is bigger than 1, we call it a stretch. But if a is less than 1, but still bigger than 0, we call it a shrink. All right? Now, a stretch means that we get steeper, and a shrink means we get shallower. All right? So we'll do an example of each, don't worry. So if we had, let's actually do something other than green. Let's do pink. So if we had y equals 2 times the square root of x, all right, if that was our problem, we always start by graphing our original square root, all right, and then I look and say, okay, well, a is bigger than 1 because a is 2. So a is bigger than 1, so it's a stretch. It's going to make it steeper. And it'll make it about twice as steep. All right, and that's because of that 2 in front. Similarly, if we had something like y equals, let's do 1/3 times the square root of x. You're going to still start by graphing your original square root. Except for this time, we have a shrink. And we have a shrink because we have this 1/3. A is less than 1, but it's bigger than 0. And so we call it a shrink. All right? Shrink means that it's going to be shallower. And it's about 1/3 shallower. You can see I'm not perfect with it, but that's okay. It doesn't have to be perfect. So we have 1/3 times the square root of x. Now, it's really important to note here, this bigger than 0 is really important because there are going to be problems that you're going to think, oh, it's smaller than 1, so it's a shrink. But remember, just because it's smaller than 1 doesn't mean that's a shrink. Because if it's smaller than 1 and smaller than 0, then it's a reflection, because then it's a negative number. All right, so just be careful with that. Okay. So let's go ahead and do a couple examples. All right, now I want to do some examples that have everything in it. All right. So we know that when we have y equals negative a times the square root of x, we'll say minus h plus k. You can see I did all of these in different colors because I'm like, there's a purpose. It's all to denote what's what. This color coordination helps me. You don't have to do that when you're doing it on your own. All right, so we know this negative sign. Negatives denotes reflection. All right, so if anytime you see a negative in your problem, you know, okay, I have to reflect this. Then we have this A. If A is bigger than 1, we have a stretch, which means we have to make it steeper. All right, if A is less than 1, but bigger than 0, then we have a shrink, and then it's shallower. All right. Then we have this minus h part. We know when we have x minus h, that's moving to the right, and x plus h moves to the left. And last but not least, we have our k. We know when we have plus k, it means we're going up. Translating that, shifting it up, sliding up. Minus k means we're sliding it down. All right? So we're going to keep all of that in mind in order to do this example. All right, we have y equals negative 1/4 times the square root of x plus 3 minus 2. So you can see this is a pretty big one because it has a little bit of everything in it. This is going to be more difficult than the ones that you're going to have to do on your own. That's okay. I'd rather do a more difficult one now so that way you can see what it looks like. All right, so every time we go through and we start this, we always want to pay attention to what we're going to be doing. We know that we're going to be reflecting, so I made sure to have some space underneath. All right, I know that I'm going to be moving to the left 3, so you can see I didn't actually draw my center line far enough to the right, so I'm going to go ahead and move that over. And I know I'm going to be moving down 2, so I want to make sure that I have extra space underneath as well. All right. Now we're going to go ahead and start. So we're going to start by drawing our square root of x. And something else I like to do is I like to list out what's going on. So I know that I'm going to have to do a reflection. All right. I also know that I'm going to have a shrink because I have this 1/4 here. I'm also going to have to move 3 units, and since I have a plus 3, I know that I have to move to the left 3. All right, so I'm going to put a little left arrow and then left 3 to remind myself. All right, and then I have my k, and k is a minus k, so I know that I'm going to be moving down 2. So I'm going to put a little minus 2 to remind myself there. All right, so now I've identified every transformation that's going on here. Now I'm going to go ahead and start drawing them. So when I draw them, I'm going to draw one at a time. You don't have to do it step by step. I only do it because I think it's helpful. So I'm going to work from the outside in. So I'm going to start, since we read left to right, I'm going to start with the reflection. I know that I have to reflect it over the x-axis, so I know that I'm going to have a curve that looks something like that. And to remind myself what that is, I just say, okay, that's a reflection. It's a minus. All right. I also have this 1/4, so I have to be a 1/4 closer. So that's going to be the next portion. It doesn't have to be exact. If you're not exactly 1/4 closer, that's okay. All right. We're not doing exactness because we are doing crisis teaching. All right. We're doing crisis learning. Like, this is all, I'm trying to teach you as much content as I can while still keeping you on track to graduate. So It's okay if we don't get absolutely everything in. All right, then I'm gonna have to move to the left, 1, 2, 3. So I'm gonna take my green, all right, I'm moving it to the left, 3. All right, and that one there, so I still have that negative 1/4 out front, but what I did was I moved to the left 3. All right, so now I have the +3 part, and the last step is to move it down 2. So move it down 1, 2. All right. So that means my new starting point is there. I moved it down 2. So now it looks about like that. So we have negative 1/4 the square root of x plus 3 minus 2. All right, and that's that pink curve. You can see that it's not exactly perfect, and that's okay. All right. One final thing I will show you though is, again, you can like skip steps by like either flipping and like moving things around. You can either like try drawing them out or try cutting a curve and cutting out a curve like on a piece of paper and manipulating it that way. Or if you like drawing out all the different ones, you totally can. The only thing I ask is that you make it really obvious about what one is and isn't the right answer. So make sure that you always have it boxed if that's the answer you want to give, or you can go through and erase what you don't need. All right, either one of those is okay. I would recommend showing all of your work though on the test, because we're gonna have a test on Friday. All right, or like a short quiz. I shouldn't say test. It's a quiz just on what we covered last week, and then this stuff. All right. I know that was a long one. What I'll do is, because this was such a long video, I'll post a couple of example problems, but they're not going to be due until tomorrow. I'll put them with tomorrow's assignment. All right, so no need to worry about practicing this just yet. I know that this was a long video. I appreciate your patience. I will post some example problems for you to try out. I also have more examples in the written notes, so if you want to look through the written notes, I do have other examples in there. But because this was such a long video, I want to respect your time. I appreciate you listening. I'll put a couple of examples for you to try out, but again, they're not going to be due until tomorrow with your tomorrow's assignment, all right? So have a good rest of your day.